I did the Atcoder beginner contest today, and I did like A3, and so I found some of these problems really cool. So I might just like go through them. That's kind of the plan. So, and sorry if I start like sound stopped up. Like my nose has like not been the best. But anyway, so you have n buildings lined in a row, and the ith building from the left has a height of h of I. Determines the building taller than the first one from the left. So this problem ends up being pretty simple. Essentially, right, like you're dating this guy, right, and you're like, there's other men in the sea, right? So the fish in the sea. So you go on a slew of dating partners, right? You have n dating partners, right? And you like find out whether it's worth it, like cheating or not, right? So that's basically this problem, right? So if you output a number like the building or that guy, right? Like it was worth it, right? Maybe. And if you have like a -1, then like, everything's downhill from there. Life's negative. Ha ha ha. Anyway, so the problem ends up being not too shabby. So that's my code. Take in the heights. Instead of Boolean, well, I said an integer. It's just, but I probably shouldn't have even done an integer. But then an integer. If the height of the ith one from 1 to n is greater than 0, then get that location, whatever. If it's not, then I'll put -1. It's not a bad problem at all. So to do it. The second problem, it's actually, I think, a well-known problem, but the problem statement is like really confusing. Like they could have made it like 3 sentences for real, but whatever. Anyway, so you have amusement park, right? And there's like, for every ride there's like unlimited amount of people that can go on it, so like k people, right? And you have n groups of people, maybe like n families or like n friend groups, whatever. Anyway, basically you have to figure out, you keep loading people onto this attraction, right? But like you don't want to split up families, right? So, and it's given that every family or like every group of people is less than the total amount of space that each ride can like accommodate, right? So you basically got to figure out, given all these families, all these people, like how long is it going to take basically to do this. So given maximum space of 6 people per ride, for all these groups of people it's going to be 4 like overall rides basically. And so the problem was a tiny bit annoying, but it wasn't like, it's nothing like crazy. I feel like it's a really convoluted problem statement. They could have probably said something better, like you have like a bag to fill or something and you're adding coins in the bag, or like you have a water, like a bottle of water or something, you're trying to minimize the amount of times you're trying to refill that bottle of water or something. But so the code's not too shabby. Again, if count plus a of I is greater than k, counts as some variable that tracks the amount of people that's on this ride, this current ride, and then I reset it every single time, so it's fine. Add it to answer, blah blah blah, and then count's not 0 at the end, add to answer. Count really shouldn't be 0 at the end, so I should probably just say ins plus plus, but whatever. So that's problem B. You can pause it too if you like want to understand. This one was actually not too shabby, so this one's actually pretty fun. You have an array of n integers, right? The integers are all less than 100 million. The thing is, you want to what's it called, like the remainder. So if the remainder of, okay, sorry, I'm summarizing this a bad way, haha. Anyway, but basically you have to find this function of every single value, every single two pairs of numbers in this array. So I don't know, like a good example is like if you have socks, right? And you like compare every single sock, right? You're comparing like every single pair of socks, right? And the number of combinations you can have is you have n socks, and then you multiply it by n minus 1 socks, basically. And then you divide that by 2 because there's 2 socks. So that's kind of actually, no, you don't. I'm stupid, but well, okay, yeah, you divide by 2 because you don't want to repeat stuff, basically. But I'm away from that anyway. So basically, you gotta find the sum of this function, right? 10 to the 8th. So you can very clearly see that if we're using C++, we need a long for this because there's no like overall modulo. You could have a number that's like 4 million, whatever. Like every number could be 4 million. And then the entire answer would just be like 4 million times n times n minus 1 over 2. I'm skipping through a little bit, but anyway, basically you just need a long to store the answer. Anyway, so to do this without exceeding the time limit, which is just 2 seconds, with n is equal to 3 times 10 to the 5, you can actually sort this array and then do like a binary search for like the index where you start to exceed stuff. You start to exceed that 10 to the 8 limit, and where you don't exceed it. So if you sort the array, and you go like sequentially each number, you can deal with all the pairs without having to deal with like excess numbers, I guess, if that makes sense. So anyways, basically sorting the array is like the best way to do this. This one's already sorted, but this one's not sorted. Actually, this one, yeah, it's not sorted. So you need to sort the array first. Dealing with, I'll show my code. It's probably the best. So you, where's this one? Right here? Yeah, okay. Anyway, so you find the prefix sums of the array, which I did here. I sorted the array here as well, took it in. And then I found out what number I needed in order to exceed this 100 million limit, and then I binary searched on the array to find out what index that was for each a of I. And I'm sorry if I'm speaking too fast because I don't want to like confuse people, but so then for the case where it doesn't exceed, so everything below that index, you can just sum that entire thing up, and then you can just sum up a of I multiplied by the range where you don't have to exceed 100 million, I guess, if that makes sense. I should probably put a visual example on here. I'm probably too lazy to do that, so you'll just have to like understand it somehow. I don't know. And then anyway, for the stuff that exceeds it, what I did was I did the same exact thing I did here, except I subtracted it by how many times it went up. So, it went over basically. So it would be the length of all the index up to like n minus 1 times max sum. And then I would add that to my answer, and I'll put that as the answer. And answer is like a long here, so I don't overflow. Anyway, that's a bunch of yapping. For D, this one was actually really interesting too. So it's like the same problem, except the better thing is that you have to take it mod this number for the entire thing, which is honestly better. But anyways, this function is not like adding and then you're doing mod. This function is just, you have two numbers and you combine them to make a completely new number. And so what I kind of noticed like early on was that this number determines what this number will be, right? Like if this is 100 and this is like 200, right? Then when you concatenate this will be 200. Okay, that's a bad example. Okay, if it's like, let's see, like 900, right? And this is 200, right? when you concatenate it, it will be 200900, right? Right. So the number of digits, sorry. But if this is like 90, right, and this is 200, then it'd be 20090, right? So the number of digits for this one determines like what times 10 to the like power this one is, if that makes sense. Like for this one, for example, this has 1, right? So it'd be 10 to the 1 times 100. That's what you have to add. And then you'd add 1. Or this one, you have 14, right? And the length is 2. So it'd be 3 times 10 to the 2, 300, and you add 14, basically. So the right number determines what the left number is. And so the right number is always like going to go from n to, I guess, 1, basically, because it can't be 0 here. So what I did, oopsies. All right, so basically what I did, this one, it's just like 10 to the whatever. I probably just should have done like power or something. I was just like too risky. I was like, I'm not willing to risk doubles or whatever. Anyway, but basically find prefix sums of the array. Again, like the last problem, just the mod. This finds out prefix sums, but I don't want to do all the like thinking stuff, so I just like put this in. Okay, sorry. Let me rephrase that. Basically, it finds the sum of an array from like L to R using this prefix sum array. You should, if you don't understand what prefix sums are, search up a video on prefix sums. I don't have the energy to explain it right now. Okay, anyway, so basically I'm starting from n-1 to like any value greater than 0. So I is greater than 0. And I'm putting this into a string. So like, for example, 314, I'm putting 14 into a string. The length was however long that is. So 14, the length is 2. And then the amount is equal to the prefix sum of, like 0 to I minus 1. And originally I didn't do it with the mod, so it overflowed. But so I do a mod, and then I multiply it by 10 to the whatever power our current number is. So like, shoot, I don't have a good example, but like, if you're a competitive programmer, you can probably think of a case where you have like a bunch of numbers, and then you have 314, and then you're adding up all those numbers before 314 to get whatever. Yeah, you get it, you understand. And honestly, I probably should have done mod after this, but I'm modding it here, so we're chilling. And then I add a of I, and I add it I times, because that's how many pairs that we can match it up with. And then I do mod on it too. And low-key, I could do a proof for why this works, but I don't have the energy to do it, so we're gonna move to the next problem. Okay, so anyway, so then this one was actually like pretty, like probably the most fun. So basically you have fxy, right? And fxy is the length of the longest common prefix of x and y, right? So if you have ab and abc, right, the longest common prefix is ab. If you have arc and ab, the longest common prefix is a, right? And then so you're just comparing all the pairs and finding their longest common prefix, right? So what I did was like, hey man, the total amount of characters, right? According to this, the total amount of characters has to be less than or equal to 3 times 10 to the 5, right? So what I did was I hashed, which is like basically a function that turns a string into an integer, like a unique integer. So you can compare two different strings with 2 different hash numbers, right? So I hashed, and honestly, I should have been more careful about hashing, because like low key, like I was not thinking about like birthday paradox, like all that stuff. But anyway, but I chose my own hash function, and like, okay, anyways, I'm yapping. Anyways, but basically, so you got to compare like each pair, right? Except that takes way too long. So you're thinking like, okay, how can I do this, right? So what I thought of was that like, for every string, right, if you go through each prefix, right, you can calculate its own hash in O of 1 time after some pre-calculation, right? So if I pre-calculate every character, right, That's O of n, if we consider n to be the length of all the strings combined. That's O of n to pre-calculate the hash values for them. And then to find every prefix, we can calculate it in O of 1 time after we pre-calculate for all the strings, basically. So a whole lot of yapping, but basically I'm computing values for each like prefix. And since we only have 3 times 10 to the 5 prefixes, you can compute the hash for 3 times 10 to the 5 prefixes, if that makes sense. So basically what I'm saying is like you can have a map basically, and that map has your length of your prefix and the hash value of that prefix. And so if you want to compare two different strings, you can compare their prefixes in the map basically. And then you can use like a not weird trick, but it's like a well-known trick for calculating these like pair stuff. But like low key, I don't know how to explain it, so I'll just show my code and then like you'll see what happens. Like, okay, so this is my hashing template. Please don't like what's it called? I don't know what it's called, but you know what I'm saying, right? Anyway, so basically, sorry, someone's calling me. So basically, oops, okay, all right. So basically, you take an n, which is your length, right? And then you have s of n, which is your strings, right? And then I have my hashing array here, right? And I'm converting every prefix into a hash and putting that into this map right here. It has count, right? And so that counts like that's the list of that's like a map of hashes given the length of the prefix basically. And then I'm going through every prefix and I'm finding how many values it has, or sorry, how many words have that same prefix. But I'm going backwards. I'm going from the size. I'm going like from the biggest prefix to the smallest prefix basically, so that I can avoid like double counting numbers, right? Like for here, oops, okay. If I had like A, B, C, D, right, and I had A, B, C, right, I don't want to start counting A's, and then B's, A, B's, A, B's, A, B, C's, A, B, C's, right? I want to count A, B, C, D, A, B, C, A, B, and then A, right? Because then if I get A, B, C, right, then I know I can like discount everything that's A, B, right? Because it's not the longest prefix. Okay, I'm so sorry if this doesn't make sense, bro. Like, but anyway, so this is my code basically, and I had to finagle with it a lot because I didn't know what I was doing like half the time, but it ended up working, and I got AC, and I'm so glad I didn't TLE or get hacked because I'm so cool like that, and I'm so glad I customized my hashing function because I love not getting hacked. Anyway. So that's basically the gist. That's what happened, and so yeah, thank you guys for listen to me yap. But anyways, I think this is a really cool problem. So yeah. All right, I'm gonna head out, but like, see you guys.